Hello everyone, hello dear students. Today we're going to talk about chapter 5, the periodic law, and specifically today we're going to talk about section 1, history of the periodic table. Okay, so history of the periodic table. By 1860, more than 60 elements were discovered. Today we know that there are 118 elements, but at that time only about 60 elements were discovered. Also, there was a problem between chemists. The problem was different chemists were using different atomic mass and properties to the elements. So different chemists were using different atomic masses. We know that atomic mass is about the mass of the atoms of the elements, okay? And they were using different properties for the elements. For solving this problem, they gathered together to solve this problem, and they held the first international conference of chemists about atomic mass and other matters, okay? So at that conference, Canizaro presented a method to measure the atomic mass of the elements, and chemists, they accepted. Okay, at that conference, Canizaro presented and talked to other chemists, and he presented a method to measure atomic mass. He said that I have a method to measure atomic masses, and after he presented, other chemists, they accepted. Okay. After 9 years after that conference, Dmitri Mendeleev came and said, I'm going to create the first periodic table. Before we talk about his job, his work, let's talk about his life. He was from Russia. He lived between 1834 to 1907. We call him the father of the periodic table. Why? Because he created the first periodic table in 1869, Pasha. Also, how he created the first periodic table. The history of his job was like that. He wrote, after he heard that chemists, they have gathered together and they decided how to measure atomic mass. So he brought he brought 63 elements and their property, their atomic mass, and he wrote on a card, okay? And he tried to solve this puzzle and create the first periodic table. So what he did, he organized his periodic table according or depend on atomic mass and properties of the elements. Basha, this is very important you to know that he created the first periodic table, or he arranged the element according to what? Atomic mass and properties of the elements. Later we'll talk about he used properties of the elements to what? To create groups, okay? And he left several empty spaces in his periodic table for undiscovered elements. This is very interesting about Mendeleev's periodic table. He left some gaps in his periodic table for undiscovered elements. And he said there are elements, they are not found yet, but later you can find these elements and they have these kinds of properties. Look, he predicted the properties of the elements that fill the empty spaces. Means he predicted the properties of undiscovered elements that they fill these gaps, okay? And also he died without a Nobel Prize. Okay, let's talk about Mendeleev's periodic table. In Mendeleev's periodic table, there were 63 elements. Pasha, this is the Mendeleev's periodic table. What you should know that he arranged the elements according to increasing what? atomic mass. Okay, nitrogen 14, then what comes? Oxygen, because it has 16. 19 does not come before 16 because he arranged according to increasing atomic mass. Also, he grouped the elements. Next slide, I'm going to explain that why he arranged the element according to increasing atomic mass. Because by this arrangement, he discovered the periodic law. This is very important that today we use periodic law to what? To understand the properties of the elements and makes our understanding better, and we can understand the properties of the elements easier. That was very interesting, that he arranged the element according to atomic mass to discover what? Periodic law. Okay, so also what else? He left some gaps. You see here, for undiscovered elements. In this book, just these three gaps like mentioned. Also, we have this gap for technetium, and he left later that element discovered. Okay, we know that he left some empty spaces for undiscovered element, and he predicted the properties of these three elements that fills the empty spaces. As I mentioned in the book, just three elements are mentioned, but he left 4 empty spaces. Okay, by 1886, that 3 elements discovered: scandium, gallium, and germanium. As I said, technetium also later discovered, but here you don't need to know because in the book it's not mentioned. But also he left what? He left, there was an exception. Okay, in his periodic table. The exception was, here you see, he placed iodine after tellurium. How? According to increasing atomic mass, iodine must come, then what? Tellurium. Okay? Why? Because iodine is 27 and tellurium is 128. We know according to increasing atomic mass, 127, which is the atomic mass of iodine, must come, then tellurium. But why he did this? We know that he grouped the elements based on their property. Okay, but if he grouped elements according to properties, look, iodine's property was similar to what? The properties of bromine, chlorine, and fluorine. So, but according to atomic mass, according to increasing atomic mass, iodine will not be in a group of fluorine, chlorine, and bromine. So he put iodine after tellurium, and at this time the iodine will be in a group of fluorine, chlorine, bromine, and we know that fluorine, chlorine, bromine, iodine, now they are where? They are in group 17. We call them halogens, right? Okay, and also after that exception, after he put iodine after tellurium, tellurium was fallen in a group that shares similar property with these elements: oxygen, sulfur, selenium. Okay, so that's why he put iodine after tellurium. Okay, after Mendeleev, Henry Moseley came in 1913. Henry Moseley, English scientist, changed what? The arrangement of the periodic table. He arranged the elements according to what? Atomic number, which is very important you to know that he changed the arrangement. How? He arranged the element according to atomic number. After he arranged the element according to atomic number instead of atomic mass, he solved the exceptions of like iodine and tellurium, okay, in Mendeleev's periodic table. How he did? Let me show you. According to atomic number, after protons discovered, Henry Moseley arranged the elements according to atomic number. So tellurium's atomic number is 52. Iodine 53. Okay, look, according to atomic number, tellurium comes before iodine already. It's not exception. So that's why he solved this exception. Okay, already tellurium comes before iodine, but according to atomic mass, no, iodine must come then tellurium. But we know that Mendeleev did not put it like that. He put it iodine after tellurium. Okay. Henry Moseley's periodic table, as we said, we have periodic law. Okay, periodic law. This is very important that you to know. Mendeleev discovered periodic law, but Henry Moseley, we can say he modified it. Okay, what's periodic law? Periodic law, it says the physical and chemical properties of the elements appear at regular intervals when elements are arranged in order of increasing atomic number. When elements are arranged according to atomic number, why it's important? We can put elements in a group according to similar property. Why do we need to arrange elements according to increasing atomic number? Look at here. We have an example. The size of atoms of elements increase down the group. Look at here. What do you see? This is hydrogen. Okay. Group 1, hydrogen, lithium, sodium. These are in the same group, but they are arranged according to increasing atomic number. What do you see? You see that the size of the elements regularly increases down the group. So this is called what? Regular intervals. A property which is the size of the atoms of the elements increase down the group regularly, not, for example, increase, decrease, increase, decrease. No, regularly increases. And across the period, what do you see? Regularly decreases. This is why this happens, because of the elements when they are arranged according to increasing atomic number. So periodic law was discovered by Mendeleev and modified by the Henry Moseley. So in section 3 we will talk about periodic law and how properties increase and decrease across the period down the group. But you see that a chemical property or a physical property element of the elements appear at regular intervals. At regular intervals here means that a property, a chemical or physical, increases or decreases down the group or across the period. For the size of the elements down the group, as we move down the group, what happens? Size of the elements increases. But how? Regularly. Why? Because of when the elements are arranged according to increasing atomic number. Okay, later in section 3 we will talk about these properties and you will understand better. Okay, modern periodic table. Since Mendeleev's periodic table has modified it many times. So what's modern periodic table? Modern periodic table is an arrangement of elements in order of increasing their atomic numbers. Basha? So Henry arranged the elements according to atomic number. Today also we use that way. Okay? So the elements with similar properties fall in the same column or group. We see that here these elements, group 1, what do you see? These elements, they have similar property. Okay? Okay, in the modern periodic table, this table that you see here, there have been some additions since Mendeleev's periodic table. You know that in Mendeleev's periodic table, there were no noble gases. There were no lanthanide and actinides. So these are added to the periodic table. So there have been some addition to periodic table over new 40 elements. Okay, we know in Mendeleev's periodic table there were only 63 elements, but after him new elements added to the periodic table, including noble gases, okay, lanthanide and actinides. So let's talk about noble gases. Noble gases discovered at the end. So it was the most significant addition to the periodic table. Okay, noble gas. And noble gas, they are unreactive, as we learned in chapter 1, section 3. And when they discovered the noble gas, where did they put? They put it where? In group 18. Basha? They put it in group 18. They added a new group. Okay? And the first noble gas discovered was helium. 1868, helium discovered on Sun first, then on Earth. Neon also in 1868 discovered on Sun and 1895 on Earth. Basha? Then argon discovered 1894, then krypton, xenon 1898 discovered. The last noble gas discovered was radon. Okay? And lanthanides, we know lanthanide and actinides discovered at the end, because some of them, we can say most of them, they are artificial. They are man-made. They are made in laboratories. And most of them, they are what? Radioactive elements. Lanthanides, when they discovered, to save space, they are placed below the periodic table. We learn in chapter 1 that to save space to the periodic table not be very wide, they have placed below the periodic table. Okay, lanthanide also, actinides. Lanthanides, there are 14 elements. Basha, they are what? 14 elements. Start from here, okay? To here, 14 elements. Each square represents an element. And this is very important you to know that they don't have group. They are not in a group. Okay, but actually they are between group 3, here this is group 1, group 2, group 3, and group 4. Okay, so they're here, Basha. They are not in a group, but they are in a period. Which period? 6th period. You see here, they placed here. Okay, the 6th period, this period. Okay. These are lanthanides, atomic numbers are 58 to 71 here. This one, this is 58 to what? To 71. Okay, 71. They have very similar property. For science, were very difficult to what? To identify or to separate the and separate their properties, okay, because their properties were very similar to each other. So it was very difficult for chemists to identify their properties. Then actinides below the lanthanides, also there are 14 elements, atomic number 90 to 103, okay? Here is 90, Masha, 90 to what? To 93, Masha, 90 to 100, sorry, to 103. These elements, they are what? They are actinides. So also they are placed between group 3 to 4, but this is important. They are not in 6th period, they are in 7th period. Okay, they are in this period. Okay, we know we have 7 period, and actinides, they are belonging to 7th period. Okay, also they have very similar property. It was difficult to separate, identify their property, and to save space they are placed below the periodic table like lanthanides. Okay, the periodicity, regular repetition. Okay, guys, periodicity is the repetition of similar properties of elements after regular repetition. Look, this is periodic table. Look at the group 1 and group 18. They are in different sites in the periodic table, but you see some similarities. How? There is a regular repetition, there is a periodicity. Look, between group helium to neon, difference in atomic number, you can look at here also. Basha, you see what? 8. The difference in atomic number is 8. Here, between lithium to sodium is 8 too. Okay? Neon to argon is 8. Sodium to potassium, 8. 8 in atomic number. You see, in both sides of the periodic table, you see the similar what? Similar properties, similar repetition, okay? Argon, look, argon to krypton, 18, and potassium to rubidium, 18. Look, 8, 8, 8, 8, 18, and rubidium to cesium, 18, cesium to francium, 32. Okay, 8, 8, 18, 18, 32. Also in group 1, 8, 8, 18, 18, 32. So this is the similarity between group 1 and group 18. Also you can see this similar pattern between group 13 to 17, group 1, group 2. Look, beryllium to magnesium, again, difference in atomic number is 8. Okay, this is an example for periodicity. Okay, this is section review. You can check. Okay, this is important. Who discovered the periodic law? Actually, Mendeleev discovered and Moley modified it. Okay. Okay, inshallah, later we will talk about chapter 5, section 2, the electron configuration and the periodic table. Okay, thank you. Thanks for watching. See you next time.